Okay, and then we can pick some other points. The trick is to just pick points that line up at nice whole numbers, and then plot those. I think that one does. No, it doesn't. Just kidding.
That way? Yeah. Sorry. Okay. And you don't know the name of the street. Does it go to the right or the left? Well, you could see it. It's just like, it's not even like a street. It's just like a little, it goes to the left.
It's very obvious.
Okay, see the building.
If you get to the end of the street, you've gone too far.
Okay, this way.
Yes.
Yeah. That way, it's like maybe 7.
Sorry. And so just plot those other points again by just reversing the coordinates. And then you can kind of sketch in the shape. To have that sideways parabola. I did a really bad job there. And again, it's just a reflection across that line. Y is equal to x. We reflected it the other way. And that brings us to an important point of, is this a function or not? So on the, and we skipped that question over here. Remember that a function means that every input has only one output. So I can look on my graph and I can see that all along this graph, every input has only one output for my inverse function. So it is a function. But over here, when I look, there are several places where when I look at the input value, there are more than one output value. So this is not a function. When something's not a function, we call it a relation or a relationship. Pam, cut it out. And then the last one is this exponential function, and we'll do the same thing. Here we'll graph the inverse function, but we're going to do it a slightly different way. We're going to do it by finding what f of 0 is, what f of 1, f of 2, and f of 3 are. So we can find those values by using the given equation and by looking at our graph. So it's best to do the equation and then look at the graph to make sure that it makes sense. So 2 to the 0, anything to the 0 power except for 0 will always be 1. 0 to the 0 would be undefined. So f to the 0 is positive 1. I can look at my graph. My function evaluated at 0 is positive 1. So we can do the same thing for f evaluated at 1, which is going to be 2 to the first power, which is 2. F evaluated at 2 is going to be 2 to the second power, which is 4. And f evaluated at 3 is going to be 2 to the third power, which is also going to be 2 times 2 times 2, which is 8. And then on this this one, we're doing our inverse function, so the inverse function of positive 1. But unfortunately, we don't have an equation for it. But we just need to look at what our previous answers were, because remember that inverse functions, when you plug in a number, it gives you out what that input was on your function. So I need to look at what my original function was and see when was 1 an output and what was the input, The input was 0, so the inverse function of positive 1 is going to be 0. And then the inverse of positive 2, the inverse function evaluated at positive 2, I need to look and see when I got that as an output and what I put in. So since this was my output and this was my input, now when 2 is my input, positive 1 will be my output. Cut it out. My inverse function evaluated at positive 4 is going to be positive 2, and my inverse function evaluated at positive 8 is going to be positive 3. And then we can plot these values. We can plot 1 as my input, 0 as my output. 2 is my input, 1 is my output. 4 is my input, 2 is my output. 8 and 3. To see what my new graph will look like, go ahead and draw in the line y is equal to x. I'm going to make the original graph, oh, sweet, a little bit darker so it shows up in the mirror better. And remember, that's just going to be a reflection across that line. And so that's the shape that it's going to take. And so I can kind of make that shape that connects these dots as well. It's going to approach the y-axis but never cross it. And that's because an exponential function approaches the x-axis but never touches it.